Welcome back to my YouTube channel GrandpaMathematics. So today we have come to the miscellaneous exercise of chapter 7. In the miscellaneous exercise, we will summarize what we have done so far and we'll do some more problems. So methods to evaluate the integrals. So normally given the integration, first what we have to do, first differentiate the denominator and see whether you are getting the numerator. In that case, the value of the integral is log of the denominator plus constant. That is the first step, just you have to check. Second one, we have to make the denominator as a single term. Once we make the denominator as a single term, then we can divide the numerator by the denominator and the integral can be written as the sum of two or more integrals. Then substitution method, in almost all problems we'll be using this method. Then that we have done in MGK 002. Then we can use the trigonometric identities and simplify, and then we can go for then that will reduce to the standard form. Then we can evaluate that integral that is given MGK 012. We can also use partial fraction, and that is given MGK 008. And in some of the integration, we can use only integration by parts. So that method is clearly explained in MGK 006 and 007. And in that particular case, integral e power x into f of x plus f dash x dx is equal to e power x into f of x plus constant is coming. Then we already seen the properties of definite integrals, and we also solved problems by using the properties of definite integrals. Definite integral is a limit of sum. We have done the derivation and we also done some problems. Then particular functions. In the particular functions, we have integral dx by x square plus a square, dx by x square minus a square, and integral dx by square root of a square minus x square, integral dx by square root of x square minus a square, and integral square root of a square minus x square dx, integral square root of x square plus a square dx, and so on. We have all seen MGK 003, 004, 005 and 009. So we almost covered all the methods. We shall solve the problems given in the miscellaneous exercise of chapter 7. So in this integration, we have 1 by x minus x cube is there in the denominator. So we can factorize this as x into 1 minus x into 1 plus x. So we can use partial fraction to solve this problem. So let 1 by x into 1 plus x into 1 minus x is equal to a by x plus b by 1 plus x plus c by 1 minus x. Multiply throughout by x into 1 plus x into 1 minus x. What we will get? We get 1 is equal to, where a, b and c are arbitrary constants. To find the value of a, b and c, first we can put x is 0. So these two term vanishes, we will get the value for a. Put x is equal to 1. This term vanishes, 1 minus 1, this term vanishes, we will get the value for c. Put x is minus 1, this will get cancelled, this will get cancelled, we will get the value for b. Substitute these values of a, b and c here. What we will be getting? Integral. When you put integral dx here, you are also putting integral dx. Now value of a is equal to 1, so it will be 1 by x. B is minus half, so plus minus half by 1 plus x plus C is half by 1 minus x dx. Now we'll simplify this. If we differentiate, we are getting dx. If we differentiate 1 minus x, we are getting minus. So put minus in here, and this also make it minus. Now on integrating, we'll get this is log x minus half times log of 1 plus x minus half times log of 1 minus x plus constant. So everywhere half is there, so this also we can write half times log of x square minus log of 1 plus x minus log of 1 minus x plus constant. So log, when you take minus commonly outside, it will become log m plus log n. That is log mn will come, so there will be x square by 1 minus x square plus constant. So this is the answer. So in this integral, we can rationalize. We can multiply numerator and denominator by square root of x plus a minus square root of x plus b. Then the denominator becomes a constant term. So this equal to integral square root of x plus a power half minus x plus b power half. Denominator a plus b into a minus b. So a square minus b square, a square. So x plus a minus b square, x plus b minus of x plus b dx. So x minus x, so we get a minus b. That a minus b we can take outside. Then on integrating x plus a power half, we'll get x plus a power half plus 1 by half plus 1. So 3 by 2 by 3 by 2 minus x plus b power 3 by 2 by 3 by 2. Now this 3 by 2 we can take it outside. So that will become 2 by 3 times a minus b. Then x plus a power 3 by 2 minus x plus b power 3 by 2 plus constant. So this is the answer. So in this integral, if this x is not there, then this reduce, this is under dx by square root of a square minus x square. But whenever square root is there, normally we'll be taking ax minus x square as y square. Here even if we take this as y square, then we have to find the value of a, again square root will come. So that is also not possible. So what we can do, we'll substitute, put x is equal to a by y. You have to remember this for this problem comes. If you know this type, then you can proceed. So this is nothing but a into y power minus 1. On differentiating, what we are getting? What is dx? Dx is nothing but minus a dy by y square. What is x? X is a by y. Then square root of a, x is a by y, so a into a by y is a square by y minus a square by y square. What becomes a minus integral 1 by y, again there is dy by y. Now you can take a square outside, then that will become a into square root of y minus 1 by y. Now this y and this y gets cancelled. So finally y minus 1 power minus half. So on integrating we get minus 1 by a, y minus 1 power minus half plus 1, half by half plus constant. Goes to the numerator, so minus 2 by a. What is y? Y is nothing but, we put x is a by y. In place of x, we have taken x as a by y. So y is nothing but a by x. So this will be a by x minus 1 power half, or you can put root plus constant on minus 2 by a square root of a minus x by x plus constant. So this is the answer. So in this integral we have x power 4 plus 1 inside the bracket. X power 4 is there here, 3 by 4 is there. So you can take x power 4 outside the bracket. So this will be 1 by x square into, when you take x power 4 outside the bracket, what will come? X power 4 power 3 by 4, that will become x cube into 1 plus 1 by x power 4 power 3 by 4 dx. So this will become x power 5. Now let 1 plus 1 by x power 4 as y. If we differentiate that, 1 by x power 5 will become part of dy. So let 1 plus 1 by x power 4 is equal to y. So dx by x power 5 is equal to dy by minus 4. So it will be dy by minus 4 into this we have taken. So this is nothing but y power 3 by 4. Now minus 1 by 4 integral y power minus 3 by 4 dy. So on integrating we get minus 1 by 4 y power minus 3 by 4 plus 1, that is y power 1 by 4 by 1 by 4 plus constant. So this gets cancelled. So we will get minus y power 1 by 4. What is y? 1 plus 1 by x power 4 plus constant. So this is the answer. We will take x power 1 by 3 outside. So in this, that means we have to divide x power 1 by 2 by x power 1 by 3. So this will become x power 1 by 6 minus plus 1. Let us take x is y power 6. Integral dx is 6 y power 5 dy by x is y power 6 y power 6 power 1 by 3, so it will become y square. Then this will become y plus 1. Now we have to divide y cube by y plus 1. So y square, y cube. So we can write this as 6 times integral y square minus y plus 1 minus 1 by y plus 1 dy. So on integrating we get y square becomes y cube by 3 6 times y cube by 3 minus y square by 2 plus y minus log of y plus 1 plus constant. So this will be 2 times y cube. Y power 6 is, from here we can write so this gives y is equal to x power 1 by 6. So 2 y cube will be x power 3 by 6, that is x power half, minus 3 times x power 2 by 6 is 1 by 3. So we have to use partial fraction method. So let 5x by x plus 1 into x square plus 9. How you can write? This is a by x plus 1 plus, for x square plus 9 cannot be factorized further, so we can write bx plus c by x square plus 9. On multiplying throughout by x plus 1 into x square plus 9, we get 5x is equal to a into x square plus 9 plus bx plus c into x plus 1. Now comparing the coefficient of x square, x and constant terms, we get what is the coefficient of x square? This side 0, this side a plus b. So now we have find the values of a, b and c. We will substitute here. Therefore integral 5x by x plus 1 into x square plus 9 becomes, that means you have to put integral here dx, again integral here dx. So a is what now? Minus half. So minus half by x plus 1 plus b is equal to half x, and c is 9 by 2 by x square plus 9 dx. Now if we differentiate x plus 1, we are getting 1. So this is equal to minus half times dx by x plus 1 plus, if we differentiate this, we are getting 2x. So we take half outside, integral x by x square plus 9 dx, then 9 by 2 integral dx by x square plus 3 square. So if we differentiate this, 2x is coming, so I am writing 1 2 here and dividing by 2 here again. Now 1 by 2 times log of x plus 1. This is 1 by 4 times. If we differentiate this, we are getting 2x log of x square plus 9 plus 9 by 2 times. This is in the form of integral dx by x square plus a square. What is integral dx by x square plus a square? That is 1 by a is 3 here. 1 by a tan inverse x by a 3 plus constant. Now very simplified, 9 3. So I change this to 3 by 2. So this is the answer. So in this problem, sin of x minus a is there in the denominator. So we have to make the denominator as a single term. How we can make? Let us take x minus a is y. Then sin y will come. So let x minus a is equal to y. X is a plus y. So sin of a plus y by sin y dy. Dx is dy. Now sin of a plus b. What is sin of a plus b? Sin a cos b plus cos a sin b. So the sin a cos y plus cos a. Now we will divide sin a cos y by sin y. We will get sin a into cot y plus, when you divide cos a sin y by sin y, we will get cos a dy. If we integrate, sin a is constant, we can take this outside. What is integral cot y? That is nothing but log of sin y. What is integral cos a dy? Is nothing but cos a into y plus constant, because cos a is constant. Now what is y? Y is x minus a. So we can write this as sin a into log of sin of x minus a cos a. This y is x minus a. I'll write x into x minus a plus c dash plus x cos a plus c. So x cos a minus a cos a plus c dash, that is nothing but c, some other constant. So this is the answer. N log m, this is nothing but log m power n. So using that, we can write this as e power log x power 5 minus e power log of x power 4 by e power log of x cube minus e power log of x square dx. Again we know e power log x is equal to x only. So that means e power log x power 5 is x power 5 minus x power 4 by x cube minus x square dx. Now take x power 4 commonly outside, x minus 1 by so this will become integral x square dx. So this is the answer. So when you see this problem, you see integral dx by square root of a square minus x square form, we can bring this integral to integral dx by a square minus x square form. If we take sin x is y. So when sin x is y, if we differentiate, what will come? Cos x dx. So that will become dy by square root of 2 square minus y square, where y is equal to sin x. Now integral dx by square root of a square minus x square is sin inverse x by a. Here it will be sin inverse y by 2 plus constant. So sin inverse y is nothing but sin x by 2 plus constant. So this is the answer. So this integral, we have to simplify this trigonometric functions. We can write this a square minus b square form. That is integral sin power 4x whole square minus cos power 4x whole square by a plus b into a minus b. So sin power 4x plus cos power 4x into sin power 4x minus cos power 4x. Now this we can write sin square x plus cos square x whole square like that. Then let us see what happens. Sin square x plus cos square x whole square. And we expand this sin power 4x plus cos power 4x. Again plus 2 sin square x cos square x is there, that we have to subtract. Minus 2 sin square x cos square x. This one only we written like this. So if we expand this, sin power 4x plus 2 sin square x cos square x minus 2 sin square x cos square x plus cos power 4x comes. This again we can write a square minus b square form, that is sin square x whole square minus cos square x whole square dx. So I is equal to integral, we know sin square x plus cos square x is 1. So this will become 1 minus 2 sin square x cos square x. a square minus b square form, a plus b sin square x plus cos square x. Into sin square x minus cos square x dx. Now this and this term gets cancels. Sin square x plus cos square x is 1. Simply we are getting sin square x minus cos square x dx. What is sin square x minus cos square x? We know cos 2x is cos square x minus sin square x. So this is nothing but minus cos 2x dx. If we integrate cos 2x, what will come? Sin 2x by 2 plus constant. So this is the answer.